Hello everyone, welcome back to my SCENIC video tutorials. In video 1, we noted the expression data and the cell information. We also created kernel variables for each cell type. We saved the cell information and the kernel variables. In this video, I can show you how to run SCENIC. Hope you already installed the SCENIC package. Then we can load the SCENIC package. To perform SCENIC analysis, the first thing is to initialize the SCENIC settings. As I introduced in video 1, the current version of SCENIC has 3 databases: mouse, human, and fly. Because this dataset is from mouse brain, so we can set the organism as mouse MGI. Let's set it. Next, we need to set the files directory for the 6 target databases, which will depend on where you save your data. I downloaded the 6 target database in the 6 target database folder. So let's set the files directory. Then you can name a title for your dataset analysis. I'm going to name it as SCENIC video tutorial. You can name the dataset to reflect your data origin. Then we can set the data as default databases. Because we set the mouse as the organism, then we are going to get the mouse database. So now we can initialize the SCENIC settings. I follow the name from the online tutorial as SCENIC options. So we will use the organism as mouse, then the files directory for the 6 target databases, and the default database. Also the title I named for this analysis. If you use the high performance computer, you can set the N cores. My computer has 8 N cores, so let's set it here for demonstration. So now we can run the initialize SCENIC function. So you can see it is going to use the mouse 6 target 500 upstream database and also the transcription start site centered 10 KB database. You can see we have an error here. It couldn't find the motif annotation for mouse. Actually, if you see my data windows, when we run the initialize SCENIC function, we created the motif annotation. It adjusts the motif annotation without the MGI specification. So we can specify the motif annotation as the mouse motif annotation. Now we can run initialize SCENIC function again. You can see now we successfully created a SCENIC options object. It is a formal class SCENIC options. We save the cell information and also the kernel variables in video tutorial 1. So now we can add the cell information into SCENIC options and also kernel variables into SCENIC options. Let's save the SCENIC options into my SCENIC folder. We can have a look at my folder. You can see we saved the cell information before, kernel variables before, and now we save the SCENIC options object. So let's continue our analysis. We have the SCENIC option object. Next step is to identify the co-expression network. So we don't need to use all the genes to do the analysis. You can see at the moment we have 862 genes in this dataset. So first we can filter the genes that are only detectable in the mouse cis target database. Next we can filter genes with an expression value bigger than 3 in 1% cells. And also we can keep the genes that are expressed at least in 1% cells. You can adjust those values according to your dataset. Depends on how big is your dataset and also how high is the expression of your interested transcription factors and their targets. So let's filter the genes from the expression data, and we name the genes as gene capped. Let's run. So you can see SCENIC finished the filtering from this dataset. Because we have 200 cells in this dataset, we detected 771 genes with a count more than 6. That's because we set 3 for 100 cells. And also, we detect 770 genes that have expression more than 2 cells, because we set it as 1% cells. Then there will be 2 cells within 200 cells. And all 770 genes are available in the RCS target database. So after filtration, we have 770 genes that we can perform SCENIC analysis. You must have interested transcription factors for your dataset. Then you can check if your interested transcription factors are in the gene list. So for example, we can check SOX9, SOX10 and DLX5. So we can set 3 factors as interested genes. Then we can check if SOX9, SOX10 and DLX5 are in the gene capped list. So let's run. You can see the character is 0. That means SOX9, SOX10 and DLX5 are in this gene set. Now we can use the gene capped list to filter the expression matrix data. Because the expression matrix data, we have 862 genes. Let's use the gene capped list to filter the expression matrix data. We can use the dim function to look at the gene numbers and the cell numbers in the filtered matrix data. You can see now we only have 770 genes and we still have 200 cells. So the second step is to run correlation using the cis target database for the genes and the transcription factors in the filter dataset. The correlation can identify positive correlation and negative correlation. The positive correlation means the transcription factor could upregulate gene expression. The negative correlation means a transcription factor could suppress those gene expression. So let's run the correlation for the filtered matrix data. Now we are ready to run GENI3 to identify potential transcription factor targets based on the gene expression in this dataset. So before we do that, we want to have a look at the files. If you press the home, the R should tell you where is your files directory. You can also set the files directory. You can see here, I have a folder named as the inter. You can create a folder in your home directory as inter. This folder is used to save the data when we perform GNE3 analysis and also the REST SCENIC analysis. So let's open the inter folder. You can see we already created two files when we filtered the genes. That 1.1 is the gene capped dataset, and also we run the correlation analysis. So let's have a look at the home directory again. You can see also there's another file named as output. We can open the output folder. You can see at the moment it is empty. When we perform SCENIC analysis, we will save the result from our analysis in this folder. So let's go back to the inter folder. Then we can run GNE3 analysis. So GNE analysis recommends to normalize your expression data. You can check if your data was normalized or not. So we can click the field expression matrix data. You can see at the moment the count value is 0, 1, or 2, so they are not normalized. So we can run log2 normalization for the data. Let's run. You can see now the data were normalized. Then we can do the next step to run GNE3. We are going to use filtered normalized expression data and use the sys target database in the SCENIC option files to identify the target genes for the transcription factors in this dataset. So let's run GNE3. You can see down here GNE3 start running. It is using 12 transcription factors potential regulators. It run part 1, part 10. You can see when GNE3 run each part, it saved the RDS data in the inter folder. Okay, so you can see there are 10 parts in total to run. GNE3 finished running, and also it saved all the matrix data as RDS file in the inter folder. We can go back to look at the output folder. At the moment you can see it is still empty. Okay, so we run GNE3 to identify potential target for each transcription factor in this dataset. Now we are ready to build the gene regulatory network and also identify the cell states. So first we can run the SCENIC rep function to build the gene regulatory network. There are two steps. The first step is to get the co-expression modules, and we can use the rep function run SCENIC1. That's step 1, co-network to modules. So let's run it. So you can see it is very quick because we have a very small size data set for the demonstration. You can see there are 12 transcription factors there. The target are 770 genes. Through the first step analysis, there are more than 31,000 possible links. So now we can run the second step to get the resonance for each transcription factor. So the rep function will be SCENIC step 2, create a resonance. So we are going to use the co-expression method as the top 5% target to save the time for the demonstration. If you don't set this co-expression method, it will take much longer time to run the second step. So let's run second step to get the resonance. You can see when we run second step, they use the database for the 500 BP upstream database, also 10 KB centered transcription stats mouse database. Okay, we finished the second step analysis to create the resonance. You can see R saved the analysis from second step into output folder. It enables from step 2 analysis. We have a TSV file for the motif enrichment and another TSV file for the resonance targets information. We also have a HTML file to show the motif enrichment preview. We will look at those files in future videos to explain the data. Now we can run the third step to identify the cell states. This is the step to score the gene regulatory network in the cells using the AUC cell package. Now we are going to use the expression matrix data. This one is not filtered. Because the data was not normalized, we can normalize the expression matrix data again. Then we can use the normalized expression matrix data, and based on our analysis for the first and the second step, to score the resonance for each transcription factor in this dataset. So let's run the third step analysis to identify the cell states. You can see through the third step analysis, we got the result and saved the step 3 files in the output file. So after step 3 analysis, we can save the SCENIC option object again. So if you have very clear cell types in your dataset, then these 3 steps is good enough for the SCENIC analysis. There are 2 optional steps to binarize the network activities, and also you can cluster the cells according to the gene regulatory network activity. I will show you both optional steps in my next video tutorial. I'm going to stop here from video tutorial 2. So I hope to see you in my next video. Please subscribe my channel if you haven't to do so. Thank you and see you next time.